All right. So I'm going to share my screen as well. Today's topic is master data management with in the generative AI era with Gemini model. So what is master data management? So you must be thinking it's something that a lot of you have not heard about probably, or master data management is not your area of interest, or it is probably not one of the focus areas when you're either preparing for industry grade applications, or you're already part of a professional world, or you're already in the industry, but you're in application development, or you're in AI ML segment, or you're only focusing on operations, that is DevOps, or you're into analytics, data analysis teams, or you're a business analyst, or in the business teams. There are so many things in software delivery, right? So a lot of you may or may not have heard the terminology, or may not have been familiar with what we call as master data management. So this is a very important area of software, or area of area in the data world for software delivery. And it is all about creating a single reliable golden version of truth. That is what we call as master data management for all your organization's most important data. So what do you mean by organization's data? It's not just the data within your organization. It could be also data for your business, the data from your business, the data from your the data that your customers use, or the data that drives your business overall, right? Any application or any product data, customer data, everything, all the data around which your business revolves, or your business results revolve, or the impact to your business revolves. Taking care of that and having a governance process around it is what we call as master data management. The difference between data management and master data management is they have the same areas of focus, except that master data management comes in with establishing that single source of truth and governance on top of the data that you just deal with. When you say data management, it could be any application that you're building. It could be a feature in a product that requires data management activities. You could just need integration with, say, an address API, or a geocoding API, or anything for that matter. That small piece of implementation may just call it data management. But in reality, when you're bringing all of this together, when you're talking about analytics, when you're talking about making an impact or influencing your business results with the data of your product and your company and your business, then that kind of or augmentation of, or orchestration of data at a, or at an industry level, or organization level, is what we call as master. Doing this data management at that level is what we call as master data management. And the data that matters the most for your organization, which we are ensuring by making sure that it is reliable and it is true and it is a single source of truth, is called as master data. So basically, it is like identifying. Let's say you're a customer. You want to go to. Let's say you're traveling a lot. You're a customer for the hospitality industry, right? You travel a lot. You go from one city to another. Probably you choose the same chain of hotels, any hotel for that matter, right? Let's call it ABC. You always stay in ABC no matter where you go, whether you go to Chennai, or you go to Trivandrum, or you go to Kolkata, but you always stay in ABC chain of hotels. Now, they identify you as a customer, so they will send you, they'll send you promotional emails, or they'll reach out to you for any customizations that you want. Or if you are identified as a privileged customer, they may even offer you some advanced promotions or offerings that they have. And they want to make sure that they do everything in their capacity to ensure your comfort, right? So let's say you are registered as, let's say I'm registered as Sukumaran in one of the sites, because I use my office email ID for that matter. And there is another site where I've registered as S Abirami. And then there's another place where my middle name is involved, right? And there is another instance across different years, right? I'm not traveling only this year, or I'm not traveling only in the last 2 years, right? I might have been traveling since probably I was in school, or I was in college. And let's say I was in college, and then even after that I was traveling. So let's say in the last 10 years, if you take even the information from last 10 years, I may have used different names, different emails, even for that matter, or different contact numbers for that matter, or different ways of representing myself, just because I've actually done that, to be honest, because at one point in my life I had a middle name, just because in my first job they asked me to fill the form, and they said this was right in college. I was selected in campus, and then I didn't want to be like, I didn't want to take a chance. So what I did is, they said fill all the columns. If you leave any column empty, you will not be, your form will not be processed. So I was like, no, 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 I'm not going to take a chance. So I'm going to fill up everything possible. So they said middle name. In reality, I didn't have a middle name, but I just took an effort to find out some middle initial, and then I filled that column in, just to, not take a chance. So for several years, I did have, not several years, few years, I did have a middle name. And a lot of the times when I recorded or I registered or something for official travel and other purposes, it became a part of my identity, right? So I have multiple representations of my name. So something like, let's use the same docs that I'm sharing right here. So let's say you have Abirami S, and then you have Abirami Sukumaran, and then you have Abirami D Sukumaran. Okay. And then you have Abi Sukumaran. And then somebody misread my name, and then they had this, misheard my name on the phone when I was trying to book something. Right. So stuff like that. Okay. No, I don't like this. Um, let's say this. All right. So they probably have different versions of my name, but now the records say at some point maybe I had a different phone number, and then I have a different phone number now, right? So let's say different phone numbers. So each entity right here represents the same person, but I may have used this. I may have gone to the same hotel ABC, right? But they know me as these different people. Now, if they don't have their data sorted, if they don't have their data, when I say sorted, it's not the ascending or descending sorted, I mean fixed. If they don't have the data governance process in place, they may not identify me as the right person, because at this time, maybe I liked to have non-smoking rooms, right? Maybe I wanted soft pillows or something of that sort. And there was a time when I opted for higher floors, right? And just that, I didn't care about whether the room was smoking or non-smoking, so on and so forth. And then I may have wanted rooms with extra cot or something of that sort, right? We don't know. So some other customization. So if they don't know who I am as a person, if they don't have the data governance process in place, they will identify these people as five different people. But in reality, these are all just one person. So right now, if I make another reservation with them, they should take into account all of my preferences and probably run it through a large language model or through an ML program that tells them that I may choose, depending on the season, whether or not she wants to be in a non-smoking room or in a smoking room, or in a higher floor or in a lower floor, or an ocean view room, or if it's summer, probably not, something of that sort, right? So that is the kind of efficiency they need to have, or data governance they need to have. And that's exactly what we call as master data management, when ultimately they know that all of these people are just one person, and these are all the requirements in summer, and this is probably what the customization they want in winter. Now, this is a bit much, but yeah, I think when you're in hospitality business, you better take care of your customers in all possible ways, right? Because that's customer experience also, and that's what they focus on entirely. So this is what we're going to do. This typically, this used a process like this, something to transform something like this into one golden record, which is like one user with one email address with one phone number, would be a very time consuming, even 6 months to 1 year long project for organizations to do this kind of master data management. I'm not talking about now. Even now, there are some organizations, traditional organizations, which are large and cannot quickly just uproot themselves from where they were into where we are right now in generative AI, right? They cannot do that all of a sudden. So they still go through this process of 3 months to 6 months. Maybe they are not doing it for 1 year anymore, but instead they probably are doing it for 3 months or 6 months, right? So that's how big of transform, or how big of an operation this master data management process used to be. But I thought, what if you reimagine this whole thing with generative AI era, in the generative AI era, or with generative AI in mind, using a Gemini model or something similar. In this case, we will use Gemini 1.0 Pro. Um, so think about that in place of this lengthy, time-consuming process, this laborious 6-month process, right? So that is exactly what we are going to do today. Instead of doing this in a time-consuming, error-prone, very labor intensive master data management task into something that's really quick, which takes very less time, even for the function to, even for the program to complete, but takes very less time for the teams to build and maintain and deliver as well. So that is exactly what we're going to do today using Gemini. But we won't look at all aspects of master data management in just an hour session. What we look at is only one aspect, which is the deduplication or match and identify. So I basically want to identify that all of these people are just one person. It's just one person. So that's what we want to do. But again, we won't do for names right now. We are going to do it for address field, address locations. Okay. So that's what we're going to do. And the only thing, the master data management is an ocean. There are a lot of things that we need to consider, a lot of things we can do, but all of those areas can use Gemini. But I've not covered all aspects of master data management. I'm repeating. We are only going to look at the match and merge aspect of it. And again, we won't be merging. I won't show whether you want to merge the duplicate into one record or you want to delete the duplicate records. I'm not going to show you what you want to do with the end result. I'm just going to show you how you can identify the duplicates and identify them as just one entity, and then do with it what you may, right? So that's exactly where we'll stop. That's what we're going to focus. And that is what our master data management Gemini's objective today is going to be. And that's what this objective slide talks about. Go to your code labs, go to overview, and just take a look at what we just discussed, and go to step 2, objective. Take a look at the data set. I'm going to talk you through that as well. So in today's session, we will talk about, like I said, address data management. So what addresses? So these are New York City bike address location data. Okay, so New York City, like we have in Bangalore, we have these bikes, right? And now here and there, we have bike locations. We also identify, there is also like certain number of bikes everywhere. You probably use your, I don't know, there is an app or something, and then you check the availability, and then you book and in advance, or you go right there, and then scan the QR code and then book from there. I don't know how it works, but then there are city bikes in Bangalore. Not city bikes, we have bikes in Bangalore as well. In New York, there is a concept called city bikes. I think it is because of, I don't know, don't quote me on it, but I think it's because Citibank sponsors them, or I don't know, it's their thing, or I don't know why it's called city bikes, but they have that. So BigQuery offers public data sets that you can use for learning and building, learning and training purposes and building prototype purposes. You can use these public data sets. So BigQuery offers many such data sets. So we are going to use the New York City bike data set from BigQuery, which has all information about New York City bike availability, location, and other data. Now, if you look at the data set itself, which we'll see in a little bit, because we're going to be in BigQuery the whole time. If you look at the data set, you will understand that the data set contains in the location information as lat and long. It does not actually have the address location. So if you remember, we did the function calling exercise in previous one of the previous sessions, I think session 4 or session 5. We did the function calling session or function calling topic with Gemini. There we exactly did the same thing. We invoked the reverse geocoding API to generate address locations from lat long. So I'm not going to say that you will use the cloud function that you deployed back then. If you have it, great, use it. But if you don't have it, or if you missed to attend that session, that's totally fine. Sorry, you missed that session. It's totally fine. What we'll do is, I have the data that will be generated from the API already exported as a CSV, and the GitHub repo link for that CSV is also made available in the code lab. So we'll do the workaround. For folks who have the Cloud Function API from that time, feel free to get the source, not the source, get the geolocation data using the API, but no pressure. If you just want to stick with the code lab right now and continue with stick with my flow, continue with it. If you want to stick with a code lab, you can go through the Cloud Function API as well. So the only step that we'll skip here in my flow is that we'll skip step 6, because step 6 is where I'm telling you how to use the Cloud Function API that you deployed in the one of the previous sessions and how to use it. There is a workaround which is in step 7, so we'll skip step 6. All right. Why? Because we need the data. We need the address location data from the lat long data. So that's exactly why I've invoked that API. But instead, you can use a CSV as well. So that's what we're going to do. So we are going to have two tables. One table will have the data directly from that public data set that's available for New York City bike. And that particular table will be the big bunch of data that is there from public data set. All of New York City bikes, maybe not all, but some of it. And it's other information like lat long, how many bikes are remaining, how long has it been, or what is the capacity left, something like that. More information. We'll see that in a bit. And there will be another table, which is going to be the table that will have the secondary information, like what you saw in this here example here, right? So the original data set itself will have all the customers, like all duplicates, and there will be another running working table where they want to compare whether this person is same as these five. So this data set will be in table one, and there will be another working table which is table two, where I have just a sample data set, say Sukumaran, right? And then there will be another one, say XYZ, that is this person's name. So now I have three records in table two, and and so many records, like infinite, or let's say 100,000 records in table one. I want to Table two is just a placeholder. Consider this as a real-time input data. I want to compare if this has a duplicate in this table, or if this has a duplicate in this table. So that this is just a sample holder, and this is all the input data, or all of your organization's data. So we are going to have two tables. This comes from the BigQuery public data set, the New York City bike data set, and this is something that we'll insert. We'll insert a couple of records for testing purposes. So we want to test if this particular record has a duplicate here, or if this particular record has a duplicate here, or if this particular record has a duplicate here. We'll check one or all three of them. Okay, so not this data exactly, but the data that we'll see in a bit. Okay, so we are going to have two tables, and how we are going to do the match and merge comparison. So that is interesting. So that is the part you will take away from the session. You are going to learn embeddings and vector search. So we already addressed embeddings in one of our previous sessions. If not, we'll talk about it. We just said a one-liner about it. We haven't actually had a hands-on with embeddings in the season yet. This is the first time. So if I remember correctly. Yeah. So what we're going to do with embeddings is we're going to convert text data into numerical format, or rather vector format, or an array of floats. That's what we call as vector format. Why are we doing this? Because we want to compare the real-time data, which is this. We want to compare the real-time data with the data in the backend, and we want to see if they are matching. So why can't you do it with actual text, and why are you doing it with embeddings? Because we want to use a vector search algorithms for matching, which operates best with mathematical or numerical information in terms of search performance and speed and scale. That's exactly why. In this example, I'm having only 5 records and 3 records for testing. But in real world, you'll have million records, right? Or more. So imagine that. And that's why we want to do a vector search instead of text-to-text comparison. And it won't be accurate as well. So a good balance of vector search algorithm with generative AI to as a fallback option would be an ideal method to go for comparing whether something is a match or not, right? So that is exactly what we'll do. So there are so many concepts in generative AI. RAG is there, embeddings, vector search is there, and then fine tuning is there, which we saw in the last session, which was on Monday. So which one to go with when we want to build an application that compares text? So I'll tell you. If your data, or if your application is all about summarizations, or you want to create generative text, but you want to follow a specific format of your industry or your organization, then use fine tuning, because fine tuning will support giving examples. You will give a lot, not just examples, but you will give a lot of training data. You have enough training data. If you already have enough historical training data that you can use to teach the generative AI, the already intelligent generative AI generic model, in this case, Gemini, if you have enough data to fine tune the Gemini model to work for your specific application, then go for fine tuning. Now, if you're building an e-commerce solution and you have, say you're selling shoes, right? You have red shoes, yellow shoes, blue shoes, leather, non-leather, other cloth material or netted, blah, blah, blah. Now, if I'm sending a search text like I want non-leather red shoes with heels 2 inches, right? So this is a plain text, but identify all the important parameters or attributes from this, and then vector search with the data. So in this scenario, you will do a vector search. Why? Because you're going to return a list of, not just list. List is not the keyword. The keyword here is you're going to return, in fact, you're going to return matches, like some yellow with blue floral pattern or yellow with white lines. You could have so many yellow. What color did I say? I think I said yellow. Okay, let's go with yellow. So let's say my search text contains this. I want yellow shoes, non-leather, 2-inch heels, right? So when I send this text, and this is an e-commerce solution, and there are multiple yellow shoes means it can be plain yellow, solids, yellow with lines, yellow dots, so on and so forth, right? Your vector search result will be able to bring in all the matches that are close. Now, whether it will be 100% accurate in leather or non-leather, you have exclusively mentioned no leather at all, but you're not saying non-leather. Instead, you're saying, I don't want leather. Right now, your embeddings may or may not interpret that accurately. It may bring in leather thinking that you're asking for leather. Not that it has to operate that way, but it is a possibility, because you may not use the word leather in the right place. You're just talking to it like you're a human, you're talking to a human being, right? So in those scenarios is when you use a fallback option after the vector matching, right? So the vector matching will do a mathematical comparison, bring in all the results, and then you use Gemini to say, hey, is my match that has been brought up by vector search is really accurate? It's really relevant to what the user is asking? If yes, send it to the user. If not, filter it then and there, don't send it to the user. So this is a scenario where you use vector search. Now there's a third case, like what we are going to do today. Just identify duplicates in the system. So for this, you can do both. You can just do a Gemini comparison, or you can do a vector search and Gemini comparison. So pick and choose what works for you. You also have other factors, design elements that you have to incorporate. It depends on your cost. It depends on your skill set. It depends. There's also RAG solution where you have information available, right? There are so many methods to implement. We don't have time to discuss everything, but today we'll do vector search and embeddings in this particular use case. All right, so we are done with the introduction. We'll get started. For requirements, make sure your browser is open. Make sure you have Google Cloud Project showing up with the billing account that we just enabled. And then before we begin, as the usual drill, make sure that copy this link, first of all, from the code lab. Go to step 4 in the code lab. In step 4, scroll to the bottom of the page, point 8, where it says, make sure the BigQuery connection, cloud function, cloud run not required, because we are not going to use that. We'll do the workaround. So just use the BigQuery, enable BigQuery API, BigQuery connection API, and Vertex AI API. If you have already used this project before and have used BigQuery and Vertex AI, you will not have to enable it. If this is the first time you're doing, I heard some of you say that this is the first time, so go ahead and do this. I'll show you how to do, no problem at all. Okay. So you can enable it using the link. Right click on this link, copy this, or you can also search it, enable it from the console. I'll show both. Okay. So here I am. This is my console.cloud.google.com, where I had open before. That is also open. Let me see. There we go. It's right here. In the search bar, no, before that, you can just open a new tab in the same browser and paste the link that you copied. So once you hit enter, it will give you a list like this. No, it'll just give you a next button. Go ahead and click next button, and then it'll show you a list like this: BigQuery API, BigQuery connection API, Cloud Run, Cloud Build, Cloud Functions, Vertex AI API. That's totally fine. Click enable button. Just make sure you have BigQuery, BigQuery connection, and Vertex AI. Those are the 3 important things for today's session. I think we won't use the Cloud Functions API. Yeah, that's it. Mine is enabled, so the enable button is grayed out. Now there is another way to enable these 3 APIs. Remember the console where you have the project listed in the drop down and you have a search bar right next to it? Go ahead and search for BigQuery in that search bar. And once you hit enter, or rather select the first option, the data warehouse / analytics. Once you select that, if it is the first time and the API is not enabled, it will prompt you with a pop-up to enable the API. Go ahead and enable it. In my case, it's already enabled, so I'm going to leave it as it is. Also, in the same search bar, search for BigQuery connection. You should see, if you scroll down under Marketplace, you will see BigQuery connection API. Click that. If it is the first time, it will ask you to enable API. Go ahead and enable. In my case, it's already enabled, so it's showing manage. Now again, go back in the search bar, remove that and enter vertex space AI. From the list of options, identify Vertex AI, one AI platform, every ML tool you need as a subtext. Select that. And if it's the first time you're opening it, it'll ask you to enable the API. Only enable Vertex AI API. Even if it is asking you to, tempting you to enable all recommended APIs, only enable Vertex AI API. Okay. That's it. Enable that and you're all set. If you already enabled it using the link, totally fine. Just wait for everybody to catch up. Okay. So, and then come back, click the Google Cloud logo, come back to Google Cloud Console, and in the search bar, go ahead and search for BigQuery again, and click that, and you should see the BigQuery console like this. The top left corner should show navigation menu. Right below that, you will see a Lens BigQuery logo, and below that, you will see the analysis migration menus. Don't touch that, just come here. Right beside that, you should see Explorer menu. This is important. Make sure you're seeing your project ID right there. In your case, you will probably not have anything if you have not created any BigQuery data set before. Right? And then to the right, you should see Welcome to BigQuery Studio, or you should see just a query editor to your right. That's it. These are the three things. Show of thumbs on if you got to this point. Show of thumbs. Okay, perfect. I'll just give a minute to folks who are still working on getting here. Just for reference, for folks who are on track already, go to step 5 of the code lab. This is what we're going to do next. Okay, so let's move on. What we're going to do here is we all know that we have already established the fact that we are going to use BigQuery queries. We are going to do this only using queries because MDM is a very data heavy concept, right? Like I already said, everything we are going to deal with in the data side. So it is only logical to bring the analytics part to where the data resides. So what we're going to do is in place generative AI. That's what we're going to do, which in place means right where the data resides. So first things first, in order to use BigQuery and store data in it, you need, any database will need a database creation, right? In BigQuery, we call that as dataset instead. Okay, so we are going to create a dataset and we need an external connection. I'll tell you in a little bit what an external connection is, but first go ahead and create a dataset. So creating a dataset, go to BigQuery page that we were on right now. Identify your project ID, and right against your project ID, you should see the vertical ellipsis, the 3 dots. Hover over it, it should say view actions. Go ahead and click that and click create dataset. You should see a sliding pane to your right that just slides in and it says create dataset. And here you will have dataset ID. What is the name of the dataset we want to provide? Provide the name that is mentioned in the code lab, which is MDM_Gemini. Copy that from the code lab, all small, MDM_Gemini. In my case, it already exists, so I'm saying MDM_Gemini1. Don't worry about it. You just go ahead with MDM_Gemini and select your location type as multi-region. So by default, it would have selected multi-region and US. Go ahead and leave it as it is. If not, select multi-region and make sure it's showing US. Click create dataset. And in about a second, your dataset is created. Right now, make sure you're able to see your project ID. You're able to see your newly created dataset right underneath your project. All right, go ahead and click your dataset. You should see dataset information. It's not important. Just Click the plus sign which says SQL query, open another tab. A blank untitled query editor should show up, and you're good to go. Close your MDM dataset configuration page. Show of thumbs how many of you completed the dataset creation step. Very nice. This is important because dataset is the main container for all the objects that we are going to create. Now, second step, we want to create external data connection. So why do we need external data connection? Because we already established that we are going to bring generative AI in place, which means to where the data resides within BigQuery. So if BigQuery needs to talk to all of these generative AI models, which live in Vertex AI, even though it is within Google Cloud, it's still another product or another service. Vertex AI is a service. It's a one-stop service for all of Google Cloud, machine learning, artificial intelligence, and generative AI solutions, right? So we will reference the Gemini model or Gemini, rather Gemini 1.0 Pro model from Vertex AI, from BigQuery itself. So in order to establish that communication between BigQuery data, your data and Vertex AI model, we need to create an external connection that will allow BigQuery to talk to Vertex AI and make sure that the service account from BigQuery is able to access that model from Vertex AI. So let's do that by first creating the connection. So how do you create the connection? Right on top of, in the Explorer pane, right? In the middle pane, right? External pane, you should see plus add button. Go ahead and click that. Plus sign followed by the word add, ADD. Again, you should see a sliding pane on your right with popular sources. Even if not, you can search for the data source that says connections to external data sources. Go ahead and click that. I already clicked it. In case you're not, you will see popular sources, right? If you don't, just type in external data and it will show up, or connections to external data source and it will show up. Okay, I'm not going to search for it because it's already visible for me under popular sources. So click connections to external data sources. Again, you'll get another sliding window, or rather sliding pane, and you should see external data source as the title for the pane, and right below that you will have connection type. Click connection type and scroll down until you see Vertex AI, remote models, remote functions, and Big Lake cloud resource. Third last for me, I don't know in which order you're seeing it. Go ahead and click that one because we want to create an external connection to Vertex AI. Now you want to select connection ID. Go ahead and look for connection ID from the codelab. You can copy paste the same thing because we will copy paste a lot of queries. So connection name is Gemini-BQ-con. It is there in step 5 of the codelab. Copy Gemini-BQ-con. Come back here, paste it in connection ID. Where can you find it? It is there in step 5 of the codelab. The name of the step is create a BigQuery dataset and external connection. Scroll down, point number 4, under Big Lake connection creation step, right here on my screen. So you have to scroll down to see connection ID. If you don't find it, that's okay. Just type this Gemini-BQ-CONN, all small. And then choose multi-region US. This should be same as the one, same as the region for data set that we created before. That's it. Click create connection button. In my case, it already exists. So I'm going to create one. You don't change anything. You should be able to create it. So now my connection is created. So what I'm going to do, if you don't see the go to connection button, expand your project, the project ID, and expand external connection. Once you expand external connections, it should list your most recently created external connection. Click that. And once the configuration, the connection info page opens, you should be able to copy the service account ID from the last row in the connection info, as you see in my screen. Just copy that service account ID and hold on to it. Show of thumbs, how many of you were able to complete the step? Avinash, if you have specific question about which step you want to repeat, just ping that. Our leads will be able to send in the text instructions for you. Okay, if you're stuck in any step one, which step? You mean the concept? Okay, you're good. Perfect. Step one was introduction. We covered that. You can always get the video to cover the theoretical part again. Okay. So now I've copied the service account. What we're going to do next is provide permissions to the service account, right? Now right click on the Google Cloud logo, open link in new tab. Once it opens, you should see the Google Cloud console page. So do this and now click the three lines, the navigation menu, and go to IAM and admin. If you don't see the pinned products, you can always search for IAM, all caps together, IAM and admin in the search bar. Go ahead and select that. IAM means identity and access management. This is where we are going to provide permissions. So you should see grant access under view by principals, right? Go ahead and click grant access. So you should see add principals tab, which says new principals. Go ahead and paste the service account ID that you just copied from the connection info. Hit enter. You don't have to select, just hit enter. It will automatically pick. Okay. Now, right below that, you will see assign roles. Click the drop down to select a role, and in the filter text box on top, type vertex vcaps, vertex space AI space user, ucaps. See, it will show up as the first item of the search result, vertex AI user. Select that and click save. So now you have officially granted permission for BigQuery to talk to Vertex AI models. That's it. Close this IAM tab. We are done with this. And you can also close this connection info tab because we are also done with this. Now, just leave one blank editor because we need this for starting up with the next steps. Show of thumbs, how many of you completed external connection creation? Okay. If there are questions or anything of that sort, use the chat. And also, if you're way behind or you feel like you need to start from the scratch, the code lab is very explanatory. Everything that we're discussing is there in the code lab as well. So feel free to go through the code lab also after the session, of course. All right. So go to the code lab. We are done with step number 5. Go to steps. We are going to skip step 6. Why? Because I'm not going to take the route of Gemini function calling right now. We already covered it in previous session. This is if you want to try it out later, but we are going to do a workaround. The only reason we wanted this is we want to use the BigQuery dataset to see the public dataset to see to actually convert the lat long values into address values. That's exactly why we need the function calling, but we are going to skip this part. Okay, so go to step 7, which is try a workaround. Yes, principal ID. So Jeevan, the principals is the one that you copied. Under principal, you should have grant access, right? View by principals. Right below that, you will see grant access or something. Click that, and once you click that, it will say it will have a search bar for principal ID. Paste your service account ID there. Leads, can you just list the steps if that's okay? Step 6 is okay. We are going to skip that for now. We are going to do step 7. Whatever we are doing in step 6, I'll tell you what we're doing. Step 6 is we are going to call a cloud function to actually, no, actually you'll call the geocoding API to convert lat long values of the BigQuery public dataset into address location value, text values. But I have already done that for you and I've uploaded that CSV. So it is all ready. So I'm just going to show you that repository and what the data looks like. Okay. So let's take a look at that. Step number 7. So I'm in the code lab. I'm in step number 7. So please go there. And point 1 under try a workaround section, it says download the file citybike_stations.csv from the repository. It's hyperlinked. Open link in new tab. And then you should see the citybikestations.csv file. Click that and take a look at what the data looks like. So as you can see, there is name of the street or address, there is lat long, capacity, number of bikes, num docs, last reported, and then full address string. So this is what I would have originally used that function calling step for, to populate this, but I have already made this available for you, so we can skip this step because we already covered function calling in a different session, and you may or may not have attended it. So that's why we are skipping that, and we are using the workaround where the data is already made available for you. So we'll use this CSV. Go ahead and click the download raw file button. You see the download button, the down arrow with the uh, bracket or square bracket below that. So go ahead and click the download raw file. You should be able to get the file downloaded. Keep it handy. We'll come back to it in a bit. Now what we're going to do is we are going to open Cloud Shell terminal. That's one more thing we need to do. And we are going to run this command bqload in order to create a table and load the data for city bike stations that we have captured in this CSV. All right. So how to go to Cloud Shell terminal? So for this, again, right click on the Google Cloud logo, open link in new tab. You have the Google Cloud Console landing page. Right beside the search bar, you should see Gemini AI chat. And right beside that, you will see activate Cloud Shell button, this tiny square. And within the square, you'll see a right angle bracket with an underscore. Go ahead and click that. It will open the Cloud Shell terminal in the bottom of your page. And you should be able to see in a bit. You'll see the terminal in a bit. I have not used this account in a while, so it's going to take a few seconds. Meanwhile, you also open up your Cloud Shell. I'll open the other account if that helps. Yeah, mine is taking a bit of time. So I'll open the other one. Really? Is my network slow? Okay, let's give it a few seconds. Few more seconds. Meanwhile, while it's loading, I'll also show you what the data looks like in the next step, right? First, let this happen on its own behind the scenes. Meanwhile, I'll go to step 8 and show you. Let's create the no, you can't create that step without the data from this step 2. No, we can actually create the table, but I can also show you what the new, we already saw what the data looks like. Nah, there's nothing to do, just wait. Okay, there we go. This one's open. We need the editor. Okay, so I'm going to open editor. What about the other account? Okay, that has also come up. Great. So what I'm going to do right now, my Cloud Shell account is, sorry, Cloud Shell terminal is open, but we also need the editor. So go ahead and click open editor. Why we need the editor? I just want to see the project structure. We are not creating any new project, but I just want to see my folder visually, and also want to upload a file, right? You can also use commands, just shell commands to upload a file that you just downloaded, but I'm just going to use the visual approach. All right, so wait until the editor comes up. My editor has just come up. And also make sure you locate the file that you just downloaded. Let me just locate that. There it is. It's in my downloads. Show of thumbs, how many of you downloaded the file and how many of you have your thing open, the Cloud Shell editor open? Yes, download on local machine. That's correct. All right. So what I'm going to do right now, I'm just going to stay in the root of my folder, of my machine, my Cloud Shell machine, right? In my case, my project, the machine's name is the folder's name is Abidi Sukumaran. That's the root. So what I'm going to do, if it is in some other folder, accidentally you selected some other folder, just escape. It will come out of it. Okay. Just press escape. You will come out of it. Now what I'm going to do is I'm going to upload this file. So how I'll upload, just open this downloads folder, your local machine downloads folder, and just drag this file and drop it on the root folder header. Okay. Just drop it there. It'll take a bit of time, but not so much time, not as much as it took for opening up the machine. Right, let me see if it has come up. Where is the file? City bike. Did it go inside Alloy Gem? Where is it? Okay, I can't find it. So better to create a folder because I can't spot it. If you are able to upload it and find your file, that's great. I have too many projects, so I can't really see where it is. So what I'm going to do is I'm going to create a folder. There is a plus. There is a folder icon with a plus button right beside my root folder's name. So I'm just going to create a new folder right here in my root, and I'm going to name it City Bike. Okay, you don't have to do it, but if you have to create it, it's good. Go ahead and do it. Okay, I did have to create it, so let me locate that. Here it is. Now I'll upload this file which I just downloaded. Okay, inside City Bike. Okay, there we go. So I have my City Bike stations file here. It's a CSV, so you can see that it's comma separated in the data as well. I'll right click this file and do rename. I want to rename it to Cloud Stations, not Cloud Stations 1, because I already have a copy of it. That's why you will not have to do this rename step, because you will not have a copy of this file beforehand. So it's totally fine. Just leave it as citybike_stations.csv. If you have this file uploaded to the root, that's also fine. If you have uploaded it to a folder called citybike, then what you have to do is click open terminal. It'll toggle back to your Cloud Shell terminal, the black screen where you can write commands, right? So since I've created a folder name, I'm going to navigate into the folder by typing cd citybike, C caps, because I used that name. So now just list the files in the directory, and I have citybike_stations.csv. Now what I'm going to do is go to the codelab, go to step number, what step is that? Go to step number 7, the workaround step number 7. In workaround, there is only one command, bq load. Copy that command, copy that to your notebook just to see what it looks like. Okay. Notepad, sorry, or whatever text editor you use, just for 1 second, right? Just see what it looks like. You should see bq load -- source format. We are saying that the source has the format of a CSV file. Skip the leading rows. And then, because that's a header, right? And then MDM Gemini, that is the name of your data set. And then citybike_stations is the name that you want to provide to your table that you will create as part of this command in BigQuery. So this BQ command is actually a Cloud Shell. It's very powerful because you're using just a Cloud Shell command to create a table and load data into the table in BigQuery using BQ load. That's exactly what we're going to do. And what is the source for this? It's citybike_stations. The / represents that it is in the current directory. All right. And then these are the fields with the corresponding data types of the fields. That's it. Now everything is intact. In my case, I just changed the name of the data set because I want it in the new data set that I create. I'll go ahead and paste it here and hit enter. And it'll ask you to authorize. Go ahead and click authorize, and then it'll open up and show your account. If it asks you to allow, give the permission, and it will take about a few seconds, and you should see that the table is created. Yes, it's done. So how will you verify this? Go to BigQuery, and just do, remember what table name we gave? Just go to the notepad and just copy this dataset name dot table name. Come back here, do a select star from and paste and run this. See how many rows of data you have. See, I have 18 rows. Okay, so data table is created, data is inserted just in one command. Show of thumbs, how many of you got to this step? Nihal, how is that possible? How can you have the table already present? Delete, drop the table and create it again. You would have already created the table. That's why it's giving you that error. All right, so step number 7 is complete. Now go to step 8. So what we have done so far is we have skipped entirely taking the data, reading the, if you see step 8, I'm zooming in my screen. If you see step 8, there is step 1 within step 8, which is create table and enrich address data. The sub step 1 in step 8 has a create table DDL, which actually reads from the public data set. We skipped all that because the next step is actually calling the cloud function, the remote function, which will convert lat long into address text, right? We have skipped both these and we are going to jump directly to step 2 because instead of this, I have already given you the CSV that contains this data, which you have just loaded into BigQuery. So we are going to skip to step 2 under step 8, which is create a second source for the bike station location data. Now imagine the second source as your real-time data. You as if you have an application and data is streaming in. Now you want to come, or in master data management, typically you have multiple sources. One source coming from Hotel ABC Kochi and another source coming from Hotel ABC Bangalore, right? Now both tables will be, one will be in the form of a CSV and another one will be in the form of a PDF. And there is data from Chennai that's coming in as a BigQuery table. Now you want to bring these 3 tables together and then run a matching process to identify duplicates. Typically, one step in MDM revolves around these things. But now instead of for that particular reason, we are going to create a second source. To demonstrate that, we'll create a second source, which is just a simple create and 2 insert statements. Remember, for testing purpose, we are creating only 2 records. Remember this that I showed you in this example, table 1 and table 2. Table 1 is what we just did, and table 2 is where we had 3 records in the demo. Here we are going to just insert 2 records, okay? And we're going to identify duplicates for these 2 records. We're almost done, so stay right there. Now what you're going to do, scroll down to step 2 in the step 8 of the code lab, and then copy the code sample that is there, the create table and the 2 inserts. Copy it, use the copy code sample button to copy it, come to the BigQuery editor, SQL editor, and paste it. Just run the create table first. It should say citybike underscore stations underscore source 2. It has created my table. Now I'm going to insert data into this table. You can run both rows together, both inserts together. It should insert it in a bit. Okay, so my inserts are complete. Okay, how many of you completed this step and created the second table and inserted records? Show of thumbs. Krishna, use the chat, please, if you have questions. Okay, so since we are close to the last step, we'll finish it and then take up more questions. But then it should be straightforward from this point on. We have completed creation of both tables. We're almost there. Now, what is left? One more DDL is left. One more definition, data definition language query is there, or statement is there rather, which is creating embeddings model. Why is that required? Because we want to remotely invoke Vertex AI embeddings from within BigQuery on BigQuery data, right? So first you will create a remote model that talks to the text embedding Gecko model in Vertex AI, and you will then use this remote model on your data that you just created to convert it into embeddings. To go to step 9 of the code lab and copy the first code sample, which is create or replace model city bike stations address EMB. Copy that, come to your uh, editor. You can remove the create table and all right now and just paste this and create this model. In a few seconds, you should see model successfully created, and then you will see a go to model button. You don't have to go there, just see that, acknowledge that, and scroll down. What we are going to do right now is I'm going to create another table called citybike underscore stations underscore source one, which reads exactly the source that you created from the CSV. And what it will do is it will store. We are just making it as a normalized structure. So I'm going to create another table to store embeddings. So it will have the data from the CSV that we loaded, and it will have the embeddings for the address location. Not all the data from the CSV, but some. Okay. So if you know, that is what we have in the select query right here. Select star from generate embedding. So this is the part which invokes the generative AI model, which is the model that generates embeddings for the address data. So where is the address data? There we go. The full address string. Remember, we saw this in the GitHub repository. Full address string actually has the full address text of the lat long value that we have stored right here. So go to the code lab, copy this code snippet. So this particular code snippet reads the address string and converts it into embeddings, and then writes it into another table for the data that we created from the CSV. So copy this create table, come back here to in the editor and run this. It'll take a few seconds and the embeddings will be created. Done. So if you're curious what embeddings looks like, just do a select star from the new table that we just created, city bike underscore stations underscore source one, and paste it right here and run this. See? ML generate embedding result. Expand that horizontally. This is exactly what embeddings looks like. Embeddings result. It's just an array of floats. Okay, that's pretty much it. And this is the embeddings result of the location text, or rather the address text, and it has the name of that particular address in this table, or rather particular city bike station is the name. Okay, go back to the code lab. So we have completed the part where we have identified embeddings. So now for one source, we have identified embeddings, which is source one. What about the second source? Remember the sample table that we created with just 2 records as source 2? For that particular source, we need to update embeddings, right? We did not create embeddings for it. This table, since it's a very lightweight table, we are going to create the embeddings within the same table. So just copy the update command, update DML statement from the code lab, step point 3 in step 9 or 8. Where are we? Step 9. Step 9 of the code lab and point 3, right? Copy the update city bike station source 2 statement. Come back here and run the update. This will take a little bit, not a little bit of time. We have only 2 rows. So yeah, it won't take much time. Just run this. What it's doing is the same, generate embedding. We generated embedding for one table. Now we're generating embedding for another table. You can't compare text data with embeddings, right? You have to compare embeddings and embeddings. That's exactly what we did. All right, so I have created embeddings for both tables source 1 and source 2, and we're all set to do vector search. So why did we do all these things? Because we want to do duplicate comparison. We want to identify duplicates for the test data that is in source 2. And how exactly we are going to identify duplicates? We are going to use embeddings and vector search. Embeddings so that you can convert them into vector format or numerical or array of float format. And vector search is the method or the approach that we are going to use of BigQuery. Behind the scenes, not behind the scenes, we will explicitly mention that we want to do a cosine similarity matching. Okay, there are multiple ways. You can also use Euclidean distance, or if you don't want to use any of these, there are other methods also to do vector search. And there is another way to do vector search. We'll talk about that first once we complete this BigQuery, this particular step in BigQuery. All right, let's first complete this. So navigate to step 10 in the code lab. So this is the last and the final step. And this is in this particular step, you have the result submission as well. So follow the instructions to run the vector search query. Okay, this will actually help you to bring this particular functionality to a lot of your use cases. So maybe this you may not be able to resonate with the use case we have in hand, but the approach we have taken to solve this particular use case will definitely come in handy when you're trying to do embeddings and vector search for your own use cases, be it e-commerce use case or any other text matching use case or address matching use case or anything of that sort. But let me tell you something, address matching is not a right use case. It could have been name matching. I just use address matching because I just wanted to compare if address was the only text that was substantial in this. Name was very short, so I used it address. Because there are other ways to do to identify whether two addresses are similar by actually calculating the distance, the physical distance between two places. But we are not doing that right now. We are only using vector search, and we are considering the address text as a text value, okay, text data, not as address data. All right. So what we're going to do right here is we're going to run a vector search on the two tables to identify if the records in source 2 are exactly duplicates of something in source 1. So this is the query for that. I'm zooming in my screen, so in case if you're watching my screen, or you can also see it at your own end in step 10 of the code lab. Select query dot name. So query, if you we have to address the innermost part at first. So vector search is a construct that we'll use. So once BigQuery sees this particular syntax in your query, it will know that you're invoking the vector search feature, and then it will look for a table which is used as a reference, and then it will look for the embeddings column in that particular reference table, and then it will look for a query that you're looking to compare against the reference table. So in our case, the reference table is source 1, the query table is source 2, and then it will look for the embeddings column in the second table, which is embeddings underscore src. I intentionally kept the names different so that there is no confusion. Okay, this is source 1. It could have been better, I understand. But yeah, I just focused on it being different. I didn't focus on it being relevant. So yeah. This is the embeddings column of source 1, and this is the embeddings column of source 2. And top k equal to greater than 2. This is actually not equal to greater than 2. This means it is using, I think this means it is using Euclidean distance, if I'm not wrong. Let me see. Yeah, the default is Euclidean. I have not mentioned anything. So by default, it will take Euclidean distance. No, this doesn't mean it's Euclidean. This just means I'm taking two nearest neighbors. All right. So I want two nearest neighbors for this particular, if there is a nearest neighbor, right? If we are not saying if there is a nearest neighbor. So that's the one catch with vector search, is that if you say I want 20 nearest neighbors, even if there is um, in reality, if they are not really the same, it will try and get as close as possible. Of course, the distance value will be very low. It will say it's really, really far away, but still you asked for 20, here is 20. Maybe the distance will be too far away, right? That's exactly what vector search will do. It's not a limitation, but that's generally the kind of use cases that we'll use vector search for. All right. So I'm saying I want two nearest neighbors, which is two duplicates from source 1 for the query or the data in source 2. So source 2 table has 2 records, if you remember, and source 1 has 18 records. That is our base table. All right. So top K, like I said, it's the number of nearest neighbors to return. Distance type, by default, it takes Euclidean. You can specify cosine intentionally. I have not done it in the first query. All right. So copy this and let's run this. Another tab, paste it. And run. So name 1 is name of the bike the name of that site or city bike station. station, name of the station from your reference table, sorry, from your query table, which is table 2. And name 2 is the name, yeah, it should be the other way around, but yeah, that's okay. Just understand that name 1 is coming in from the query table, which is our table 2. And name 2 here is, it's identifying this as its duplicate and providing it as a, providing the distance. All right. So if you notice, it has sorted in descending order. The last one, Allen Street and Hester, Allen Street and Hester, right? These are exact duplicates, and that has the closest distance, which means it's saying this is the nearest neighbor, which is almost, distance is almost 0, right? Which means these are alike. So it has identified the duplicates exactly. Now, you may wonder, why is Broadway and 29 and Broadway and West 29? It makes sense, right? They're not exactly the same, but they are similar. So it has identified it as second nearest neighbor. Okay. So for the two records that we had, it has identified. So we had, if you remember, in source 2, we had inserted 2 records. So go back to what we inserted in source 2. I think I deleted it. But if you go to the code lab and go to step number 8, scroll down in step number 8, code lab step 8. If you see the insert 2 records, we have inserted Allen Street and Hester and location Broadway and 29. So go back to your BigQuery editor. You would see the result, Allen Street and Hester, location Broadway and 29. For each of these, our vector search query has identified 2 duplicates. One is exact match and the other one is somewhat similar, right, with the corresponding distance. So that's about it. Go to the code lab and go back to step 10. That's where we were. So scroll down. We completed the first query, that is Euclidean. If you're interested, or be interested, actually, just run the other query. Copy this. This is the cosine similarity, cosine distance method. I don't know if it's cosine distance or cosine similarity. There's a difference. Similarity will order it differently. Similarity will say how close they are. Distance is for how far they are. So the ordering might differ. So be careful in understanding what tools support cosine distance or cosine similarity or Euclidean distance, right? Be careful in what it is showing, but you can somewhat make it out from the response as well. So I'm going to copy this query. Go ahead and copy. This is the result of this. This part is what you will submit as a screenshot for this session. Okay, so copy the second query. The only difference between these two is that in the second query, we have explicitly mentioned that the distance type is cosine. Right? Go back here, open a new tab, run, paste this, and run this query. I have ordered it by descending, which tells me that this is cosine similarity. Yes. Okay. So as you can see right here, similarity is 1. So in this case, the label for distance should be similarity because it is actually cosine similarity. So if I run this, you will see that Allen Street and Allen Street have a distance value of 1, which means not that they are far. It means it's cosine similar. How similar they are. The similarity is 1 almost, which means that it's same. Okay. So that's pretty much it that we have to cover. This result screenshot is what you want to submit. This part right here, what is highlighted in the code lab here. This part is what you want to submit for this particular session. The link to the app where you submit the result is available in the pinned message. I'll send it again. But one thing I wanted to tell you as part of this step is we have not, if you notice, we have not indexed the data for vector search. Why is indexing important? What is indexing? It's a very important concept in databases. Those folks who have worked with data for a long time or who have just started with databases would have or will be interested to know this because you would have heard about indexes a lot, or if not, it's a good thing. Index is basically a pointer to something in memory, right? So why is indexing used? So that your search performance can increase and the speed of result for searches is increased, right? That's exactly why we want indexes. So it will speed up your searches. But when is it effective? when your data is more, when you're dealing with excessive large amounts of data, you would want to create indexes. So what you want is, if you so what you want to do is that go ahead and create with index. That is also possible. I haven't covered that in this code lab, but there is links to documentation, and just search for BigQuery vector search with index. You will get the documentation link. Just Google BigQuery vector search with index. It's just another construct that you'll use in the query. The only difference is it will create in it. It has to create index for you, but in some case, what BigQuery will do is it will intuitively create the index and make it available only if your data reaches that point of excessive querying and excessive reads and excessive usage, because unless that happens, index will be an overhead. So BigQuery intuitively decides whether or not to create and use an index unless it feels the need for it. It will still keep a placeholder if you insist on creating it. Okay, so you can create it if you want. It won't impede on the performance, because BigQuery will choose to not use it, and it'll ignore it if you have very less data, or if you don't search on that particular indexed field a lot. BigQuery will ignore the index, just so your application is not slowed down. But always design it clearly, design it properly. Don't create unnecessary indexes. Create it when it's absolutely necessary, because it will help in the performance of your searches and matches. So right now we have completed identification of matches. So where is MDM in this? You can choose to merge these records, or just flag them as duplicates and then use only one whenever required, or consolidate this and call them as golden records. Do whatever you want after this, right? So this is just to demonstrate how generative AI can transform how you're using master data, or how you're doing master data management. You would think we did not use Gemini here. We only use embeddings and vector search. That's a good thought. So this is a follow-up for you even after you submit the result and everything. If you have I know a lot of you have not heard about Project Sadhana. This is something where you come up with your own ideas or work on extending a code Vipassana application that you've already done, which means you build on something on top of what we have already built, or you come up with your own idea. So one suggestion is here is, get the result and then ask Gemini whether these are really duplicates or not. For example, Allen Street in Hester and W43 Street and 10th Avenue, they are not duplicates, right? So use Gemini. Even though the distance, the similarity is almost zero, it is still identified as a similarity. Can you return this to the user? No. So to make the decision of whether or not to return this to the user, you can use Gemini 1.0 Pro to make the decision of whether or not this should be flagged as user response. So with that, I'll end today's session. Show of thumbs, how many of you successfully generated embeddings and did the vector search step? How many of you got vector search results? Duplicates. Perfect. Very nice. Those who have not completed, don't be discouraged. The code lab is pretty detailed and pretty self-explanatory. Go ahead and try it at your own time. A few gotchas or things that you may have missed is that if you already have the table created, and if you insert it once, or if you make any changes in the CSV, it will first create, if you already have the table and then try to load it, it will try to append the data to the already existing table, and in which case it may not identify the data to be inserted as the right data type. So what you have to do is drop whatever table you already have and create it, do the BQ load command once again. Nikhil, I know that you've been unsuccessful in creating that particular step. Don't worry, just follow the instructions in the code lab. You have workarounds there. Just be mindful of read the instructions clearly and follow it. It's pretty self-explanatory. You wouldn't slip or you wouldn't miss anything if you follow the instructions. Complete it and submit the result screenshots. Just one screenshot. So here is the screenshot that you will submit. This is the one. And I'll ping the link to the application in the chat right now. Ask the questions in the chat, please. And also, I'm going to stop recording. Please use Discord channel also for questions after we end the session. I've just pinged the link in the chat for app submission. All right. So I'm going to stop recording first. By the way, the next session, let me talk about that after the recording ends. One sec.